All right. Last problem on the team round from 2015, chapter competition. Personally, I prefer the problems that have what's them called? Diagrams. Congruent circles P and Q are internally tangent to circle O and externally tangent to each other at point O. As shown, circle S is internally tangent, so essentially all of this is saying, quite simply, the drawing just looks the way it is. That everything is touching in exactly one point, and that this distance right here is going to be 12. PQ is 12, which makes 24, which makes that 12, and that makes that 12. And so I'm looking at this, and it is asking us, what is the diameter of circle S? So I'm trying to find this value right here. Well, the best strategy that I can think of when we're dealing with a diagram is, so let's start making some shapes, shall we? And the most logical shape when I have 3 points, is a triangle. And this is clearly going to be an isosceles triangle. And I'm going to drop this down. And so we have a right angle. And at this point we need to start trying to find triangular relationships that make sense, that would help inform the side length. And in particular, we need to find this distance here, or you can think about it this distance from here to here. I'll draw over that in maroon. So essentially we're looking for this here, or that there, depending on your point of view. All right, so we've made this nice little triangle. We've dropped our altitude, and we have a right triangle. This seems like a Pythagorean theorem problem to me. And the Pythagorean theorem says a squared plus b squared is equal to c squared. And I have this value here. It's 12. And I know, well, let's say x marks the spot, shall we? So we know that this side length, the hypotenuse, is going to be my 12 plus the x. So that means we have 12 plus x, or x plus 12 squared. And I know that my a value is going to be 12 squared. So now I need an expression for my green side. There's my green side. Okay, well, I know we have point O, and so this is a radius of the large circle. Well, I know the radius is going to be this distance to here and here, and I know this side is equal to this side, so that's another 12. So I know this whole green line is 24. But that's not the height of the triangle. The height of the triangle is the 24 minus the radius of the small circle, x. So that means we have 24 minus x squared. And now we have a problem that we can solve. So let's solve it. 12 squared is 144 plus, so 24 squared, boy, I don't know 20, but I have a calculator. Maybe I should learn my squareds to 25 squared. So we have 576. I'm going to multiply this as a square binomial, so I know I'm going to end up with minus 48x plus x squared. So this piece here is this, so I'll change colors here, make it a little easier to follow. So we have our 144, that hasn't changed. My green is my green, and then my maroon, using the same idea, is going to be x squared plus 24x plus 144. And right away, I can tell that I have x squared on both sides, so the x squared will cancel out. That's nice. Now I have a nice, easy quadratic expression, or linear expression to solve. So let's add the similar terms. So 576 plus 144. So then, it almost feels like I'm going to get, oh no, we're good. So then let's add 48x plus 48x. So I get 72 is equal to 72x plus 144 minus 144 minus 144, and I will get, oh, that's funny. Why didn't someone just say I had 144 on both sides? So I get 576 is equal to 72x. So divide both sides by 72. And I get x equals 8. And don't forget, x marks the spot. No, x is the radius of the small circle, and so the answer is 8 for the radius. But we're not being asked for the radius, we're being asked for the diameter. What is 8 plus 8? That is 16.